So carbon monoxide is a toxic and hazardous gas. So substituting the carbon monoxide with the carbon dioxide is a really desirable and ideal approach that we can use carbon dioxide as a carbon resource. So we are focusing on that conversion of the carbon dioxide to the value added chemicals.
Welcome back to another amazing episode of the Clampanoir Show. This episode is in collaboration with CSIR, Indian Institute of Petroleum. In this collaboration, you would see a series of 8 episodes featuring eminent scientists from CSIR IIP who are actively working to build an Atmanirbhar Bharat while decarbonizing India's energy footprint. On today's episode, we are speaking with Dr. Sumanlata. Did you know that the capture of carbon dioxide and its conversion into chemicals and fuels is recognized as one of the most effective options for carbon dioxide mitigation? But how do we do that? How do we actually convert that carbon dioxide into chemicals and fuels? What kind of technology, what kind of processes does it take? On today's episode, we have with us Dr. Sumanlata, who is going to break down this all for us. Someone who is actively working in green chemistry. And if you want to know what green chemistry is, this is the episode for you. I hope you enjoy the conversation, and while you do that, please don't forget to hit the subscribe button. Welcome, Dr. Sumanlata, on the Clampanoir Show. So, the technology that we're talking about today is photochemical activation and conversion of carbon dioxide into chemicals. थोड़ा बताओ इसके बारे में कि क्या technology है ये?
As we know that in the recent decade, energy and environment are the two major issues, and one of the major issues is the global warming, and that is mainly causing due to the increasing concentration of carbon dioxide due to the excessive use of fossil fuels and our development. So there are many ways to mitigate that carbon dioxide. We can capture it and sequestrate it, but one of the ideal approach that we can use carbon dioxide as a carbon resource. So we are focusing on that conversion of the carbon dioxide to the value added chemicals. It's our core area of research. So but another problem with the carbon dioxide, it is a very stable molecule, so its activation requires excessive amount of energy. So that if we are going through the thermal processes, that energy requirement that deactivate the catalyst. So in our approach, we are activating the carbon dioxide under the ambient conditions like room temperature and atmospheric pressure, and using the sunlight, solar light. So it's a renewable resource, and we are just taking the substrate and carbon dioxide and using the sunlight in presence of a specific catalyst, and we are getting the products. So this particular technology is the conversion of carbon dioxide and methanol to the acetic acid. So acetic acid is a very important ingredient in the various applications like various polymer chemistry, pharmaceutical compounds, so and so forth. So, so far 3 processes are known for the acetic acid using the commercial processes, but all the 3 processes, they are using the carbon monoxide. So carbon monoxide is a toxic and hazardous gas. So substituting the carbon monoxide with the carbon dioxide is a really desirable and ideal approach. So if we look at the literature or open literature, so only 2 processes are known for the utilization of carbon dioxide as a carboxylating agent for the methanol to acetic acid conversion. But both the processes, they have drawbacks of using the higher temperature, like the reactions are being carried out at the 650 degree temperature or 450. So our research or our process is world of its own kind in the whole world, where we are activating the carbon dioxide using the ambient conditions like 25 degree temperature and 1 atmospheric pressure of the CO2, using a recyclable catalyst, and irradiation time is 12 to 24 hours, and we are taking the methanol, carbon dioxide, and producing selectively the acetic acid. So it has the salient features like the reaction is being carried out at the ambient conditions. We are using the solar energy for the activation, and it is the utilization of the carbon dioxide. So we are fulfilling that requirement to contribute towards our green environment or so and so forth. So it has a huge scope in the future. So it's a new area of research activating the carbon dioxide using the photocatalysis. So although some of the research are known, but they are using just photocatalyst and carbon dioxide to get some C1 chemicals like methanol, and conversions are very low. But in our area, our research, we are using the carbon dioxide as one of the feedstocks with another organic molecule to convert into some valuable chemicals. And conversions are the quantitative like 90%, 80% with the selective formation. So that is the main key salient features of our technology.
And जो chemicals like you are converting them into, like these chemicals, like what are the use case scenarios, and like I want to know that how is this, like in a way benefiting, for example, industries at scale.
Yeah, like for example, if we talk about the acetic acid is a huge market. है ना, in the polymer chemistry, we are bearing the clothes in the formation of the esters in the pharmaceutical chemistry. So acetic acid has a huge applications and its market is growing. Acetic acid is being used in the ester formation, है ना, in the vinegar formation. Acetic acid is being used in the food industry में it is using as a additive. So acetic acid is multiple applications, like in the pharmaceutical chemistry में as a acetylating agent it is being used for the production of some specific chemicals. So for example, like acetic acid, if we are replacing the carbon monoxide with the carbon dioxide, so it is having a huge applications or huge benefits, not only for the environment but also economically, because carbon monoxide is quite expensive. On the other hand, carbon dioxide is easily available and it's kind of waste. So we are valorizing one waste product to another value-added chemical.
Have you quantified like what kind of impact does it like have? Do you have the numbers for
We
it?
did not quantify the amount of CO2 which is being used, because in our reactions right now we are using the stoichiometric, means we are saturating our solution with the carbon dioxide. But of course in the future we'll look all these factors like economical factor, mass balance, and we'll take care of all these things.
And is this process like currently being used in industries?
No. This process its own first time we patent, but it is having our own patent on this process. So अभी recently one is the जो bottleneck है in this process, that is we are using the batch photoreactor. So we want to switch from the batch to the continuous mode so that we can approach the industries for the further applications. So for the continuous process, we are collaborating with our sister laboratory, that is Indian Institute of Chemical Technology in Hyderabad, CSIR, IICT. So those fellows, they are having the engineering knowledge and we are the chemists. So our knowledge is complementary. So whatever we are developing here in batch, they are producing in the continuous mode. So that work is under progress right now.
It's like amazing, like because chemicals are used like everywhere, like every industry it
Yeah.
has huge application, and the way you're making that process also, I would say, environmentally in a way that it has a positive environmental impact.
Yeah.
That is amazing.
Yeah.
So like give me some areas where like some other areas as well where you are employing these little steps towards making or what you call that green chemistry.
Yeah, like green chemistry concept is a very growing area, because everyone is it's a all concern for all of us about having the good environment to our survival and so and so forth. So apart from that CO2 utilization, we are also working on the green solvents, like we are using the ionic liquids. Ionic liquids, they are the liquids, but they are non-volatile. So like we are replacing the volatile solvents like जैसे dichloromethane and benzene. These are the volatile solvents. So they are giving the volatile organic compounds as a pollutant in the environment. If we are replacing those kind of solvents with the green recyclable solvents, so they are also means benefiting our environment. They are also contributing towards the green chemistry. And similarly, we are developing the heterogeneous catalyst. है ना, कि those catalysts we can separate and we can recycle those things. So waste production is minimum. We are producing the less amount of waste, and we are replacing some reagents like chlorinate, like methylating agent. Those conventional methylating agent, they produce lot of halogens. So we are using some green methylating agent like dimethyl carbonates. So we are working towards totally for the environment, and totally our research is focused towards the CO2. That is also a part of the environment.
And how are today, say, pharmaceutical industries, employing the concepts of green chemistry or working towards, environment?
Yeah, as we know that pharmaceutical industry, they produce maximum waste, है ना, because if we are preparing one pharma product, it should be purity is very important factor, and multi-step synthesis, they involve the multi-step synthesis, and every step they produce the waste. So management of that kind of waste, how to dispose it off, that is a very very challenging issue. Like if we are using the corrosive acids after the reaction, what we have to do with those corrosive acids, or so people are focusing towards the use of these such of the green things, like they are using the ionic liquids, they are using the aqueous solvents, water they are using as a reaction medium, so that at least waste production can be minimized. And pharmaceutical industry, they are facing a lot of challenge, because the pharma industry is producing the maximum amount of waste.
What kind of waste it is?
Mainly they are acidic and basic alkaline waste they are producing, because in the every step they are using the sulfuric acid, hydrochloric acid, NaOH. So those are effluents they are getting, and that is really a challenge to dispose it of.
And because if we do not dispose it of correctly, it's again
Ha,
going to
yes,
harm the.
yes. So those things are the people have to, and they are also focusing on these things, because recently we are associated with the DST. They have some program on the production of key intermediates. So environmental factor is the main focused they are having. Ki how much waste you are producing and how much it will be benefited than the other things, or those are the reported things. So they wanted us to give all those benchmarks na, ki what we are producing, what were the bottlenecks, and how you will approach ki so that ki waste production should be minimized, or so that.
And you're also telling that carbon dioxide utilization has a huge opportunity. So, what are the opportunities that exist there?
Yeah, one of the major opportunity, like we are mainly transportation sector, we are producing the carbon dioxide from the transportation sector. So if we could convert the carbon dioxide into the fuel, because fuel is nothing than the hydrocarbon. So there are a lot of research for conversion of the carbon dioxide to fuel. If we can convert the carbon dioxide in the fuel, so it will establish a carbon cycle, and that will be a fantastic. If we are producing the carbon dioxide, again we are reusing it to get the fuel. So, carbon dioxide conversion to chemical, it's a really ideal and promising approach rather than dumping it, because we are utilizing something. But it has some drawbacks. One is the stability of the carbon dioxide, and another is the opportunities or industrial commitments, because a lot of chemicals which industries are producing from the carbon monoxide, those are ideally can be produced from the carbon dioxide as well. But industries, they don't want to switch, because they all have their own setups for the reaction, so they don't want to take risk. So that industrial commitment, socio-economical commitments, they are poor, but day by day a lot of research is going on. So in the near future, carbon dioxide conversion and utilization, it's a huge area of research, and it will be growing like anything in the near future.
Give me like a few researchers that you have come across, or probably you are working, that you feel can have an exemplary outcome if if it is used in industries or at large scale.
Yeah, Abhi, at present, everybody is working on the CO2 utilization. If you approach any IITs or ISER or any CSIR lab, those are dealing with the chemicals. Everyone is working on the that carbon dioxide. But I have various collaborations in the abroad also. We are having some collaborative projects on the CO2 utilization. So across the world, people are working on the CO2 utilization, and mainly photocatalysis is the recently growing area in this regard. So it has really has a future, and in the next means 10 years there will be something on the industrial scale. We are very sure for that. Other chemicals like carbonates, or acids, esters. So whatever carbon, any compound that is having the carbon can be produced from the CO2. They are having the one or more challenges, but if we could overcome those challenges, any chemical can be produced from the carbon dioxide, because carbon dioxide has a C1 carbon. So that carbon can be used for the production of any chemical. So there are various processes. If we are hydrogenating it, we can get the hydrocarbons. If we are coupling with other organic compounds, we can get some platform chemicals. So opportunities are increasing, lot of opportunities are there, and based on the current research scenario, people are trying many things. So they are converting carbon dioxide into the alcohols, ethanol, like, because ethanol blending is currently growing. So based on the requirement of the industries, and based on the research available, people are trying many things and many chemicals they are producing.
And what are the areas that you are particularly passionate about?
Uh, Particularly in the near future, I am very much passionate about this CO2, because something should be on industrial scale. So some for commercialization we will try. Apart from that acetic acid synthesis, we are also working on carboxylation using the CO2. And one of the waste stream that is producing from our in-house waste plastic conversion plant is there. We have one TPD capacity, one waste plastic to fuel conversion. So there is one cut, that is a naphtha cut. So we are valorizing that naphtha cut with the help of CO2 to getting the carboxylic acid.
What is naphtha like?
Naphtha, it's nothing. It is a hydrocarbon that is having the alkanes, alkenes, various components, the mixture of the various components. So we are targeting particularly the olefins in that naphtha. So that naphtha has a huge amount of olefins. We are using those olefins for the carboxylation using the carbon dioxide. So that is also a very, very growing, challenging area, and it has a huge potential for the commercialization. because all the refineries, though refineries having such kind of matlab waste streams, so they are looking for the valorization, and nothing can be better if we can valorize those things with the CO2, because in the refineries lot of CO2 is there, so they are looking for the opportunities to use the carbon dioxide for some value addition.
And what would you say are some of the opportunities for entrepreneurs wanting to enter into this space?
Yeah, they can we can also approach, and people can also approach us. Some of the bottlenecks are there, like we want to in the photocatalysis, the main challenge is the residence time is too high because our reactions took 24 hours, so it is too long. Another thing, only batch reactors are known. Photocatalysis can be done in the batch, so there are opportunities to develop the continuous photoreactors to decrease that residence time. So once these limitations will be overcome, I think people will have faith on that photocatalysis, and it has a scope.
Definitely. Thank you for being with us
Thank
today.
you. Thank you
And,
so much.
like, thank you for sharing with us all that, because we generally don't get to, hear that side of the
Yeah,
story.
thank you. Thank
So,
you so
thank you for
much.
making chemistry actually green.
Thank you.
Thank you
Thank
so
you so
much.
much.